All right. Hey, how's it going? Yeah. So here's another episode. I guess Tetris was considered episode 32, so this would be episode 33. And I'm gonna, I guess, just get rid of this program right here that I had made. It was kind of interesting, basically. If you don't know what the Collatz conjecture is, it basically means that whatever number you start with, it's going to be a natural number greater than or equal to 1. But if it's even, you just divide it by 2 and then you get another number. But if it's odd, you multiply it by 3 and you add 1. Now, they've never proven it, but it's believed by many mathematicians that if you keep iterating, no matter what number you start with, you will always reach 1. And then there's a little cycle that goes from 1 to 4 to 2 to 3 again. So there's a couple programs that I can make. One of them basically starts with a number and then it gives you the, it iterates until it gets to 1. Or I could start with a number and I could kind of randomly go backwards, and which is what I had programmed. But I decided that I wanted to make a Collatz tree traversal kind of game thing, if you will. So basically we'll have the option to kind of, I guess, crawl around the tree. So let's just go ahead and do that. So basically we're going to start with, I guess, it could be a random number. Or it could just be 1. I guess it doesn't really matter. So let's just start with 1, I guess, and then we're going to make a loop that will just kind of continue, and this loop will allow us to do a couple things. So we're going to have a couple options. So 1 is, or our current number, which is going to be a, I guess, is either going to be even or it's going to be odd. And depending on which one that is, that will tell us the number kind of previous to us. However, there's another kind of thing. No matter what number we are on, we can always double it to get an even number. However, we can't necessarily always divide it by 3 and add 1, I mean subtract 1, to get a number that's going to be odd. So, for example, okay, so 5 times 3 plus 1, that'll give us 16, right? Which is our reverse number. But so to go backwards, or to go down kind of like this infinite tree and kind of explore more numbers, we basically would do this. And basically we result in an odd number, so that means this is valid. But for example, if we did 18 minus 1 divided by 3, that's not an odd number right there. And in fact, it's not even a whole number. So it has to result in an odd whole number for this to be valid. So here we go. Yeah. So we could take a number like 6, multiply it by 3, and add 1. And then we have 19. So then if we have 19, and we subtract 1 from it and divide by 3, of course we'll get 6, but that's not a valid transformation because 6 is not an odd number. So let's go ahead and do this. And so the first thing we're going to do is we're going to check if a is an odd number. So we're going to divide a by 2. And the way we're going to check is if we're going to check if the fractional part of that is equal to 0.5. Okay? Now this isn't really going to change much. It's basically just going to tell us how to find what our previous number is. So we're going to call that number b. So if the fractional, if the fractional part of it divided by 2 is 0.5, then that means it's odd. So b is going to be a times 3 plus 1. Otherwise, it's going to be a divided by 2. So we figured out b, and now we know a. So that's kind of half the information. Now we got to find out kind of what can generate this a. So it's either going to be 2 numbers or it's going to be 1 number. And depending on what our kind of, I guess, our parent number, or I guess it depends on whether let's see here. It depends whether or not the number that gets to us would be odd, I guess. So basically we can we can just multiply a by 2 to get c. So no matter what, we're going to have that c. But then we're going to find out if we're going to have this d number. And the d number is kind of an optional thing that depends. It's not optional, but it sometimes exists and it sometimes does not. So what we do is we take a minus 1 divided by 3 and store that into d. And then I think d has to be odd, basically, for it to be a whoa. Well, we're not making Tetris here. Sorry about that. Oops. So let's see. How do we do this? Okay, so one of the things I want to do is I want to kind of draw everything. So there's going to be 4 numbers that we draw. We need to check if d is valid, and I guess we'll store that into e. So we're going to check. We're going to say if, I guess, fractional part of d divided by 2 equals 0.5, then we're going to store 1 into e. Otherwise, e is going to be 0. Okay, so that basically says that if d is odd and whole, then e is going to be our option here. Okay, so then we're going to output at the top. So I'm going to put in the first row. So I'm going to put 1 and then like, what's halfway across 15, I guess, like, or 25, I guess like 17 maybe. And we'll put b. And then like 2 rows down or 3 rows down, I guess 4, we'll put a. So that's our current number. So then we can see our parent, we can see our current number. And then kind of below that, we're going to put our 2 numbers. So we're going to put one at like 5 and then one at like 18 or something, I guess. I don't know. Or 17. We'll put one at 4 and 17 or something. So this will be 8 for C, and then 8, 17 D. But that will only show up if we have a D. Okay. And we want to clear the screen first. So we're going to clear the home, we're going to draw these, and then we're going to do a kind of, we're going to do like a weighting thing. So we're going to get whatever our key is and store it into G, and then we're going to just kind of loop to make sure that we actually get an input. Okay. And then there will, and we'll change A if we have to. So we can get an input but not necessarily change A, which means the screen should just kind of refresh, I guess, if we press the wrong key. So let's go ahead and do our options. So we're gonna press up if we want to change to B and kind of restart. So I'm gonna go with 24, I think. So if G equals 24, then we're gonna set our new A as whatever B was. If G was 20, actually wait, no, that's 25. 25 is up. If G is 24, that means we're trying to go left, and so C is going to be our new A. And we'll also do it if we press down. So we'll say if G equals 34, which is down, then C is going to be A. But then if we press right, that'll give us another option. So if G equals 26, then D is going to be our new A. And then I think, well, since these are at 17, I'm going to change these actually to like, well, what's half of 25? It's not really 17, is it? It's more like 12, right? Yeah. So I'm going to change those to 12. And what I'm going to do is I'm going to change this 4 to a 12 depending on what E is. So, oops. So basically, it's just going to make it look nicer. So pretty much the default is going to be 12. And we're going to use F for that, just because it's the next variable. So then we say if E, we're going to, instead of using 12 for F, we're going to use 4 as F, and then we're going to just put F there. So if we have our option E, it'll be on the left side. Let's go ahead and check this and see if it works. Ooh, so we're at 1, and we can decide to go to 4 or 2. So if I press up, we're at 4. Nice. That's really cool. And then 4, we can either go up the tree or we can go down. So 4, we have the option for 2 or 8 or 1. So if I go up, we should go to 2. And then we should go to 1. So if I keep pressing up, we should be in this loop where we go 4, 2, and 1. And if I press right here, we should be at 1. Good. If I press down, we should be at 2. Good. If I press left, we should actually go to 4. Good. Okay, so if I press right, we should go to 1. Cool. Now let's go to 8. So I'm going to press left. Cool, now we're at 8. 8 only has one option. It can double, but it doesn't have an option to kind of branch the other way. So we're going to go to 16. And notice from 16 we have 2 options. So we can go to either 32 or 5. So I'm going to press left and go to 32. And then down, 64. And then let's go right to 21. Well, 21 has 42. 42 has 84, 168, 336, 672, 1... Ooh. Interesting. Okay. So there might be an issue here. There might be an issue with the 0.5, because this is the thing that's weird, is none of these numbers Okay, I guess those numbers are splitting. I don't know, I'm just kind of going randomly. But yeah, you can see how it gets big pretty quickly. I'm kind of surprised that, I'm not sure why, but anyway, but yeah, when we go down 21, there's 42, 84, 168, 2688, and I'm surprised that 2688, hmm. 1344. Interesting. So, yeah, that's Collatz. I guess that's a really quick program, which is nice because I don't usually do that quick of programs. But there you go. We have a Collatz tree that we can just traverse down, and it's really fun. And you can kind of see how to get to different numbers, and just by pressing down, left, right, and up, and there you go. I don't know why it's not branching here. It might not work here for larger numbers because the 0.5 might get screwed up somehow, but I'm kind of surprised that this one doesn't branch, but that's okay. Seems to work for the decently smaller numbers. So yeah, see if you can prove the Collatz conjecture. I might make a video about that and how I tried to prove it one time and how I actually convinced myself for a short period of time that I actually had proven it and then realized what my mistake was. So I'll see you guys later. Thanks for watching.